Limits graphically. Often in calculus, we talk about x approaching some number. For example, say x is approaching 5 from the left-hand side of the graph. Then x is getting close to 5 from the left. In calculus, we mean really, really close to 5 from the left. In fact, in calculus, 4 is not considered to be close to 5. Now, 4 9/10, that's starting to get close to 5 from the left, but we can do better. Another number that is closer to 5 from the left than 4 9/10 could be 4 99/100. Can we get even closer? Sure, we could do 4 999,000. Or we could even say 4 9,999/10,000. And you can keep going with this list to get closer and closer to 5 from the left. We see that the numbers that we came up with for this one are showing. So now let's identify a number that's closer to 5 from the right. Well, if we wanted, we could do 5 1/10 as a starting point. We could do 5 100th. We could do 5 1,000th, or we could even do 5 1/10,000th. And we're continuously getting closer and closer and closer to 5 from the right-hand side. And here we can see that the numbers that we were talking about and came up with are included in this list as well. Now let's discuss an algebra problem. Suppose we have the graph of a function f of x is equal to x cubed minus 1 all over x minus 1. Well, for all values of x except for x equals 1, you can use standard curve sketching techniques. The reason that it has no value at x equals 1 is because the curve isn't defined there. If we put 1 into our function here, it's going to be 1 to the third minus 1 over 1 minus 1. Well, 1 to the third is 1, and 1 minus 1 is 0. And more importantly, 1 minus 1 is 0 in the denominator, and that's not allowed. Because we're not allowed to have 0 in the denominator, and we get 0 over 0, we can actually end up factoring this to show that this factor will cancel out. And when the factors cancel out, it creates a hole that is in the graph. In order to get an idea of the behavior of our function or curve around x equals 1, we're going to complete the chart that's shown below here. We're going to figure out the function's value at 9/10, 99/100, 999 thousandths, 9,999 10,000ths. And we're also going to do the other side, which would be 1 1/10,000th, 1 1,000th, 1 100th, and 1 1/10th. And to do that, let's actually switch over to a calculator. And I'm going to use Desmos, and we're going to add a table. And for y1, I want to make it to be f of, and we're going to make it x1, so that whenever we put the x value in there, it's going to give us our function value. All right, so our first one that we had in that table was 9/10. Second one was 99/100, 999 thousandths, 9,999 10,000ths. I'm going to skip over 1, and we'll do 1 1/10,000th, 1 1,000th, 1 100th, and 1 1/10th. We can take these values and fill them in our table. And we can see that as x gets closer and closer to 1, the value of the function gets closer and closer to 3. This is approaching 3 from the left, and this is approaching 3 from the right. The informal definition of a limit is, what is y doing, or the function doing, as x gets close to a certain number? The function doesn't have to have an actual value at that particular x coordinate for the limit to exist. Limits help describe what happens to a function as x approaches that value. In other words, a limit is the number the function is trying to reach or attain. If we want the limit of the function f of x as we approach the value of c from the left-hand side, we write it in this notation. Notice that there is a minus sign or a negative sign in superscript of the value of c. That tells us from the left-hand side. If we want to find the limit of the function f of x as we approach the value of c from the right-hand side, we will write it in this notation. And again, notice the plus sign for the positive side or the right-hand side is given in superscript above the c value. The one-sided limit of the function f of x as x approaches 1 from the left is written in this notation. So again, notice we have the negative sign in superscript above the 1, and we're taking the limit of our function f of x as it approaches 1 from the left. And we can substitute the actual function algebraic expression in for f of x and write it as the limit of x cubed minus 1 over the quantity x minus 1 as x approaches 1 from the left. And if we analyze the graph and come to the value of 1 from the left, we see that the limit is 3. The one-sided limit of the function f of x as x approaches 1 from the right-hand side will be written as the following. So we have the limit of f of x as x approaches 1 from the right or the positive side, so the plus sign is in superscript, and we can replace f of x by its algebraic expression, x cubed minus 1 over the quantity x minus 1. And as we analyze the graph and approach 1 from the right-hand side, we see that we do indeed approach 3.